Okay, so here we will do the solutions to these system of equation problems. Okay. The first system is y equals 6x minus 11. So here y equals 6x minus 11. Okay. To adjust the contrast a little bit here. Okay. So y equals 6x minus 11, and then the other equation was negative 2x minus 3y equals negative 7. So negative 2x minus 3y equals negative 7. That's our first system of equations, and we need to solve for this system. So how do we do that? Well, we have to take each of these equations, and these together form a system. Okay, we have to solve for each one. Now, the first equation is already in y equals mx plus b form. Okay, now the second equation is in standard form, so before we can actually solve it, we have to put it into slope-intercept form, or y equals mx plus b form. So we'll do that here. Negative 2x minus 3y equals negative 7. Okay, so in order to get this in y equals mx plus b form, I have to add 2x to both sides, and that cancels the 2x on the left because negative 2x plus 2x equals 0, and I'm left with negative 3y equals 2x minus 7. Okay, so now I'll divide out negative 3y on both sides of the equal sign. Sorry, that should just be negative 3, not negative 3y. My apologies. So now what? Now we have to divide negative 3 by negative 3, which gives us 1, so y is alone. And we have y equals 2x minus 7 over negative 3. Okay, so we're almost there. We just have to remember that this common denominator can be split up among the terms in the numerator, like this. Y equals 2x over negative 3, and then we have minus 7 over negative 3. And as you can see, we've got a little bit more work to do. I can actually pull this negative 2/3 out and set it next to the x like this. Y equals negative 2 over 3 x, and then this negative 7 over negative 3 can just be plus 7/3. Okay, so now I have this equation that was in standard form. The same equation is now in slope-intercept form. So the part where we do substitution starts now. We're going to set these two equations, y equals 6x minus 11 equal to negative 2/3 x plus 7/3. Okay, so I'll do that right here. We just write 6x minus 11 equals negative 2/3 x plus 7/3. Okay, and now I just solve for x right here. So I'll add 2/3 x to both sides. And this will cancel out. Negative 2/3 x plus 2/3 x. That cancels out because they add to 0. And now I'm left with 6 plus 6x plus 2/3 x minus 11 equals 7/3. Well, in order to add 6x and 2/3 x, I have to get 6 in terms of 3 because we need a common denominator to add the coefficients. So here I'll think in my head, what divided by 3 equals 6? Well, the way we do it is, what's 6 times 3? It's 18. So 18 divided by 3 equals 6. I can rewrite 6x as 18 thirds x plus 2/3 x minus 11 equals 7/3. Now I can add these coefficients. These coefficients are the numbers in front of the x values. So 18/3 plus 2/3 gives 20/3 x. So 20/3 x minus 11 equals 7/3. So now I add 11 to both sides to get rid of it on the left. Well, negative 11 plus 11 cancels out, and I'm left with 20/3 x equals 7/3 plus 11. Again, we have the problem on the right where we can't add 7/3 to 11 until we have a common denominator. Because right now, this is really 11/1. I can't add uncommon denominators. So I've got to find a common denominator. What divided by 3 gives 11? You say, well, what's 3 times 11? 33. So in order to have a common denominator, I need to multiply 11 times 3 and 1 times 3. So that's how we do that, multiplying the top and the bottom by 3. And so I've got 20/3 x equals 7/3 plus 33/3. Well, now I can add these. 7 plus 33 equals 40. So I have 20/3 x equals 40 thirds. Okay, so now how do I get rid of the 20 thirds x? I want x by itself. So I multiply 20 thirds by its reciprocal on both sides. The reciprocal of 20 thirds is 3/20ths. And I'll do that to both sides. These 3's cancel out, these 20's cancel out, leaving x by itself. So now I have x equals, before we start writing anything, just take a look at this. These 3's can cancel. Just saves us some time. So now I have x equals 40 over 20. Now reduce that fraction. 40 divided by 20 is 2. So x equals 2. Okay? Well, now my job is quite simple. I just need to plug 2 everywhere I see an x in my original equation. I'm going to substitute that 2 value for the x. So we'll do that. Over here, say, well, remember, y equals 6x minus 11. So if I'm going to substitute a 2 for the x, I'll say y equals 6 times 2 minus 11. 6 times 2 is 12. So y equals 12 minus 11, which equals 1. So y equals 1. That means that the solution to this system of equations, x comma y, over here, the solution is the x value I found of 2 and the y value I found of 1. X comma y. Okay? And that's how you solve number 1. This is number 1. Okay, so once you get that done, you can move on to number 2. Number 2 says (2x minus 3y equals negative 1). And then below that I have y equals x minus 1. So that's my system right there. This is the system of equations. Okay, so I don't have to do anything to this equation because it's already in slope-intercept form, y equals mx plus b. Right, but I do need to do some work for the first equation. I have 2x minus 3y equals negative 1. So I will subtract 2x from both sides. That cancels out on the left, leaving negative 3y equal to negative 2x minus 1. Remember, by convention I put the x terms in front. So now I divide by negative 3 on both sides. Remember to divide the entire right side by negative 3. The negative 3's cancel on the left, leaving y by itself, equals negative 2x minus 1 over negative 3. Okay. Well, remember, we can pull this denominator and put it underneath each term in the numerator. So I have y equals negative 2x over negative 3 minus 1 over negative 3. Okay, so do a little bit more work. Remember, I can pull the 2 and the 3 kind of out of this fraction and write it y equals negative 2 over negative 3x, and then minus 1 over negative 3. Almost done. So now I remember a negative divided by a negative is a positive, so I have y equals 2/3 x, and then negative by a negative is also a positive, plus 1/3. And now I have rewritten the first equation from standard form into slope-intercept form. There's the slope, there's the y-intercept. Okay, so if you were going to graph this line, you would need to get this in order to graph it. Well, now let's substitute. Let's set these two equations equal to one another and solve. I'm going to set 2/3 x plus 1/3 equal to x minus 1 and solve for x. So I'll have 2/3 x plus 1/3 equals x minus 1. Now it's just a matter of getting x by itself. So I'll subtract x from the left and subtract x from the right. These cancel. Now I have 2/3 x minus x plus 1/3 equals negative 1. In order to subtract this x from 2/3 x, I need to find a common denominator. That's where it's important to remember that hiding in front of every x is a 1. So I need to write 1 in terms of 3. So what I'll do is I'll multiply that invisible 1 by 3 over 3, and I'll get 2/3 x minus 3/3 x, because 3 over 3 is just 1, plus 1/3 equals negative 1. Okay, we're on our way. What is 2/3 x minus 3/3 x? Well, it's just negative 1/3, right? Okay, so 2 minus 3 is negative 1. So I end up with negative 1/3 x plus 1/3 equals negative 1. Now, in order to get x by itself, I just keep moving terms around. I'll subtract 1/3 from both sides, and that will leave me, because this 1/3 minus 1/3 cancels, it leaves me negative 1 over 3 x equals negative 1 minus 1/3. Okay, well, we're still in the same boat. I need to subtract 1/3 from negative 1, but I need to get negative 1 in a common denominator form with 1/3, or negative 1/3. So I can write negative 3/3 for the 1. So I'll write negative 1/3 x equals negative 3/3 minus 1/3. Alright, so that gives me negative 3 minus 1. What's going to happen there is it's going to get bigger in a negative sense in the numerator. So I'll have negative 1/3 x equals, and then negative 3 minus 1 is negative 4. So I have negative 4 over 3. Now I need to get rid of this negative 1/3 x on the left side. I need x by itself. So I'll multiply by the reciprocal, which will be negative 3 over 1. Okay, I'll multiply both sides by the reciprocal of the coefficient I want to divide out from the left side of the equation. Now pay close attention here. So these 3's cancel and these 1's cancel. Everything cancels, leaving x by itself equals, now I can take a look at something here. I have a negative times a negative, so it's going to be a positive number over here. But I can cancel these 3's. I don't have to multiply them through, which just leaves 4. Okay, that last step again, I had negative 4/3 times negative 3 over 1. The 3's in the numerator and denominator cancel, and these negatives multiply together to give me a positive, so I'm just left with 4 over 1, or just 4. So x equals 4. Well, now that I know that x equals 4, I can just plug that back into my easier equation, y equals x minus 1. Let's go down here and write y equals x minus 1. Plug in the 4, so y equals 4 minus 1. Therefore, y equals 3. So that means that the intersection point of those two lines, the solution to the system of linear equations here, is my x value of 4, comma, my y value of 3. So that's the x value and the y value. And that is the answer to number 2. Okay. We'll jump to number 5 now, because that was a graphing one. And on number 5, I'm given y equals negative 2, and I was also given 4x minus 3y equals 18. Okay, this is number 5, just so we don't get confused. So again, this is my system. I already have one equation in slope-intercept form. Remember, y equals negative 2 will be a perfectly horizontal line passing through negative 2 on the y-axis. But I need to get this at a standard form. So what I'll do is I'll start working on this guy here. 4x minus 3y equals 18. And the first thing I'll do is subtract 4x from both sides. Okay, these cancel here on the left, leaving me with negative 3y equals negative 4x plus 18. I now need to divide both sides by negative 3. And these negative 3's cancel on the left, leaving y by itself. So y equals negative 4x plus 18 divided by negative 3. Remember, I can split these up, so each term of the numerator gets a negative 3 in the denominator. So I have y equals negative 4x over negative 3 plus 18 over negative 3. I got to clean this up a little bit. Now I can pull out that 4/3. Y equals, remember it's negative 4 over negative 3, so that's the same thing as positive 4 over 3. 4 over 3x. And now I have a positive over a negative, 18 over negative 3, so this is going to be a minus 18 over 3. Okay, so can we simplify that y-intercept? Sure we can. 18 divided by 3 is 6, so y equals 4/3 x minus 6. So now that I have this equation, I can set it equal to my other equation. And this is going to be a rather simple one. So I have my first equation, which is just negative 2, because I'm just going to take this part of it, equals 4/3 x minus 6. Okay? So what I want to do now is get x by itself. So I'll subtract 4/3 x from both sides. Okay, these cancel, and I'm left with negative 4/3 x minus 2 equals negative 6. Okay, so I just want to keep trying to get x by itself. I'll add out 2 on both sides. These cancel, negative 2 plus 2, and I'm left with negative 4/3 x equals negative 6 plus 2 leaves negative 4. Alright, so now in order to get x by itself, I multiply by the reciprocal of negative 4/3, which would be negative 3/4, and I'll do that on both sides. Okay, now pay close attention. These 3's cancel and these 4's cancel, leaving x by itself. So x equals, now before I start writing, I'm able to cancel out the 4. This is a little bit confusing here, so pay close attention. I can cancel out these 4's, and what's left in their place is a 1, just so we remember that. There's a 1 there and a 1 there now. Okay, so I end up with a negative times a negative is a positive. I end up with just 3. The 4's are gone, but it's not leaving a 0 behind, it's leaving a 1 behind. When you cancel numbers out, it leaves behind a 1, not a 0. So I have x equals 3. So if x equals 3, what does y equal? Well, we were already given that y equals negative 2, but it might be useful to check our other equation. Remember, we were told that y equals 4/3 x minus 6. So if I plug in that 3, I'll get y equals 4/3 times 3 minus 6. So y equals, and now 4 times 3, well, I could multiply 4 times 3 and then divide by 3, or I could just see that this 3 will cancel with the 3 in the denominator, and I'm just left with 4 minus 6. So what's 4 minus 6? Well, it happens to be negative 2, which is a good check. It matches what I thought I was going to get. So let's see what I know. I know that the solution to my system is the x value I found of 3 and the y value I found of negative 2. Right, that's the intersection point of those two lines, which we are now going to graph. Okay, now you should be using graph paper, but I'll just draw one. Oh, where am I going to put this? Okay, so we'll label this axis y, and this axis we'll label x. We'll put a 0 here at the origin. And then I need to use my ruler to create some little hash marks. -1, -2, -3, -4, -5, -6. Okay, and that means this is 1, 2, 3, 4, 5, 6. And then same thing here. 1, 2, 3, 4, 5, 6. Okay, so this is -1, -2, -3, -4, -5, and -6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So first we'll plot that first curve, y equals -2. Remember, all that is a line passing straight through the y-intercept of -2. That's perfectly flat because the slope is 0. So we draw this straight line passing right through that y-intercept of -2, and we'll label this line y equals -2. Now it's time to plot the other line. Here's the equation of the other line, y equals 4/3 x minus 6. So the way we plot these lines is we go to the y-intercept, which is -6, and we start there. And then we look at rise over run. So in this case, the rise is 4 and the run is 3. So starting at -6, I'll go up 4, 1, 2, 3, 4, and then run 3. 1, 2, 3. So that point right there. Okay, so I can connect these two dots now and make a line. Okay, and the equation of this line is y equals 4/3 x minus 6. The key point here is where these two lines intersect. They intersect right here. Now, what are the x and y coordinates of this intersection point, or this point where these two lines intersect, the intersection point? Well, the x value is 3, and the y value is -2. Okay, the whole point of this exercise is to see that that matches what we found algebraically. If you do this in your graphing calculator, you'll find the same intersection points. So that is the solution to number 5. Now I want you to use real graph paper to do this, so you have the help of those little boxes and you don't have to use a ruler to create your own graph. Otherwise this might not work out. If your graph is just hand drawn, it might not be very precise. So that is the solution to number 5. And we'll stop there because at this point I have shown how to solve two systems of equations using substitution alone. And then for number 5, we solve the system of equations using both the substitution method, and we graphed it to prove that the intersection point was in fact our substitution solution of 3, -2. So this problem number 5 gives you a look at kind of the whole spectrum of what you can do with substitution. And you should work on these, and really in all of the problems, if you have the time, you should go ahead and graph them, because practicing this skill of graphing will help you in so many ways as you move forward with your mathematics. Substitution will also help you. Just kind of the mental exercise of doing this algebraic manipulation will make you smarter and will make you think more logically. And it's also very satisfying, I think, if you've gone through the work, to find out that, hey, the answer I found using all this math right here matches what I found graphically. It's also nice to find an answer that matches the calculator exactly. So, especially in a graph. So that's how you do number 5. And we'll stop the recording there. Hopefully those 3 problems will help you solve the other 7.